Well, what's up, everybody? Got another video here for you. We're doing some growth and decay problems. Here's one of the examples. It says a radioactive substance decays according to the formula A of T equals 100 times E to the negative 0.02 T, where A of T is the amount in grams remaining after T days. T is positive. T is greater than or equal to 0. We're not going to do negative days. What is the half-life? So they want to know what the half-life is, which that means time for half the substance to decay. All right, so it's nice that they give us the function here. A of T is equal to 100 e to the negative 0.02 T. So there's our function, and we want to know what the half-life is. Well, the half-life, we need to know how much is present initially when T equals 0 right at the very beginning. So we can see here that A of 0, because that's at time T equals 0, that's right when it starts. That's going to be 100 times E raised to the negative 0.02 times 0, which is 100 times E to the 0, which we know that's 100 times 1, which equals 100. So that's the amount present initially. Okay? And we know now that the half-life occurs when A of T is equal to half of the initial. When it's half of the amount present initially, which would be 100 divided by 2, which is 50. Okay? All right, so basically we want to know, when does 100 e to the negative 0.02 T, when does our function here, when does that equal half of the initial amount? And what's half of the initial amount? That's 50. We want to know, when does that equal 50? Okay, so we've got to solve this for T. So I'm going to divide everything by 100, and so that's E to the negative 0. Let me write that a little better. 0.02 T equals, 50 divided by 100 is a half, which is 0.5. All right. So now we have to solve this. So we've got an exponential equation here. So to solve that, we can just take the natural log of both sides. All right. And we know over here the left-hand side is negative 0.02 T is equal to natural log 0.5. So now the big question in the room is, what happened to the left-hand side? What happened to ln and E? That's usually the question most students have. Well, let's do a quick little review on some logarithm properties. So the log of b to the x with base b is equal to x. Whenever the base of your exponent and the base of the log, if they're the same, your answer is just your exponent. And then the other thing we need to know is that the natural log of x is equal to the log of x with base e. So what happens, instead of writing log base e, it's just like we're abbreviating that with ln. So whenever you see ln, natural log, that means the same thing as a log with base e. Okay? And so what we have here is the natural log. Now let me change back to this color. We've got the natural log of e to the negative 0.02 t Well, remember, ln is the same thing as log base e to the negative 0.02 t. And you can see that the base of the log and the base of the exponent are the same. So that is just going to give us the exponent, and that's where this comes from. Okay. And so now we will divide both sides by negative 0.02, negative 0.02. And so we will get t is equal to, and then you have to punch this in here. Well, I mean, look, if you wanted to, you could leave it like that. That's an exact answer. If you're in my class where you don't get to use a calculator because I'm just so mean, you'd leave your answer like that. But if you plugged it into the calculator, you would get 34.66, and that is t is in days. And that would be your answer. So, you know, your teacher lets you use a calculator. There you go. If you're in my class where you can't use a calculator, you'd leave it like that. All right, so I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment, and I'll see y'all in the next one. Later.